This call is now being recorded.
So we are looking into the data structure. In this data structure, we are looking the heap data structure. The heap data structure, which will be consist of three different parts. One is binary, binomial, and Fibonacci. So in this syllabus, we are going to look after only the binary heap. So binary heap, which want to be representation of two properties. One thing will be that it want to be a complete binary tree. That is the first property. And second, either the binary heap has want to be in a property of minimum heap or a maximum heap. That will be depends upon your program. If any one of the cases you are writing, that will be fine for this property binary heap. So we have seen some of an example of binary tree, full example of binary tree, min heap, max heap, and all. So we have seen this application of tree that I have told you that the sorting methodology, that is a heap sort methodology, and priority queue that we will discuss in this class. What is mean by priority queue? And these are some of an operation that we are going to do. That is insert, delete, extract maximum, decrease key, and decrease key. These are all the operations in the heap structure. So in yesterday class we have seen about the heapify up, that is an inserting a new node, and heapify down, that is a deleting a root, deleting a node which can be done at the node that what we want to delete, that node want to be replaced by the last element of the node, and we want to delete those things. And we have discussed the insertion operations and all. And now I want to give the clarity that how it will be the array representation. In yesterday class itself, I have told how the data will be stored in a heap tree. So the data will be stored in an array representation in a heap tree. It means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, and 10. So what is the first element will be stored here?
Zero level elements of
100.
100.
And whether it is a maximum key or a minimum key, minimum heap.
Maximum.
Maximum. So the maximum heap, the root node will be stored first, that is 100, and next will be
50.
50,
50.
70.
Yes, I told you that this is a level order. It means it will be travels from level to level. It will be travels from level to level. So it will be 50, 70, 10,
10, 30,
30,
30,
40,
40,
50,
40, 50,
17.
17.
1, and 7. So if you are having an array over there, it will be a null. So now you can tell me that which one is a root node here. Root node in the index value. This is
0.
the root node. This is the root node, right? It will be consist of an index value 0. In an array, the index value will be starting from 0, and the root node left child will be present in the index value 1, and the root node right child will be present in the index value called 2. Right? So this is a default thing. If you are having a complete binary tree, like the first step will be like this. The first 3 steps will be like this. If you are having more than level 1 or level is equal to level 1. If you are having the tree which more than level 1 or equal to level 1, the structure will be like this. The first element will be stored in a 0th position, that is a root node, and second element, the left child, will be stored in the first position, index value 1, and the right child will be placed in the index value 2. So now coming to this, we have stored already. We have studied in a VSPP lot of array program we are studying. If you want to find out the ith position in the array, what do you want to do? If you want to find out the ith position in an array, you just take it. If you want to find out the fifth position in an array, so consider that this is list 1. So what is the basic structure here to find out the fifth position in a list 1?
Calling index value.
Calling by index value. That means you want to type the array name and you want to find out the fifth position. You want to find out the fifth position. 2, 3, 4, and 5. So this is 50 will be placed in the fifth position. So it will be present. The output will be 50. So this you all are aware about that, right? Yes.
Yes, sir.
Yes, the index value. Based upon the index value, you want to find out the value, find out the element. Shivakarthik, yes. Yes, thank you. So this is the you have know this, and you want to find out the parent of the particular node. If you want to find out the parent of the particular node, apart from this three node, you have seen. I have told you that the first node will be the root node, and the root node child will be the 50 and 70. You all know that the root node child will be 50 and 70, and remaining we having six nodes over here. You want to find out this 40th node parent. You want to find out. You want to find out the 40th node parent. For this, I minus 1 floor division of 2. Now, what is the ith position of 40? 5, right? Index position. Yes.
Yes, sir.
Yes, sir.
5 minus 1
4.
floor division of 2. What is the value?
2.
0.
2. The value will be 2. 5 minus 1, that is 4. 4 floor division of 2 will be 2. So the 2 value, you can see here the 40 parent will be 70. The 70 was stored in the index position 2. Clear?
Yes, sir.
The 40, if you want to find out the parent for the remaining nodes, if you want to find out the parent, this three node will be constant. First will be the root node and the left child and right child. If you want to find out the parent for the remaining node, then what we want to do, the ith position of that particular node minus 1 floor division of 2, then you get the parent node over here. Yes. And if you want to find out the child node for the particular node, you want to find out the child node for the particular node. If you are going with left child, then the formula will be 2 into I minus 1, sorry, plus 1, 2 into I plus 1. So now I want to find out the child node, left child node of a node called 10. I want to find out the left child node of 10. So what is the I value there for 10?
3.
3,
2 into 3 plus 1. What is 2 into 3?
7,
6. 6
So
six,
plus
7.
6
6
and
6,
7.
6 plus 1, it will be 7. So what is the seventh index position here? 4, 5, 6,
1.
and 7.
1.
So,
1.
so you can see here the 10 will be my parent node and the left child node will be 1 that was stored in an array in the seventh position. So likewise, you can find out the whether in array point of view, you can find out which one is a parent and which one is a child. So now you will go with now we'll go with to find out right child of the node. To find out the right child, 2 into I plus 2. So same thing, I want to find out the right child of 10. So it means 2 into 3 plus 2. What is the value?
8.
8. So this is my index position 8. So for this 10th parent node, the right side value will be 7. You can see here the 10th parent node, the right side value will be 7. So as like that, to avoid this three element, it will be a default that will be stored in your process. And remaining how many elements are there? If you want to choose any one of the element, and you can find out the parent node or you can find out the child node for that particular node. So for that, the formula will be there. So I will share you this formula in your notes. When you are sharing the notes, I will share you this. It you can be asked in your 2 mark to find out the parent of. They will give you a root over here, and they will ask you to find out the parent of. They will give you like this. They will give you an array in your 2 mark and ask you to find out the parent of 30 or a child of 50. Likewise, they will ask you. So when they are asking that, you want to do this operation with this formula. So that is.
Sir, not audible.
Yes. So what are the operation you have done in the theory part? What is the major operation?
Insert.
Insertion will delete.
Insert, delete, and heapify. This three operation only, right?
Yes, sir.
Yes. For this, I am not going to use the functions over here. The functions code will be very difficult. So I am working onto it. The functions code, I am working into it. The function code. So before the function code, I will tell you how the heap, the function codes. That means we are going to describe a class, whatever the normal code what we have used in the previous program. Same type of coding will be available for this heap also, for minimum heap and maximum heap. So in this class, I am not going with the function code while describing a class or a function, calling a function and doing an operation for the heapify and doing the operation for heap up and heap down. This thing I am not going to do in this program. I am just going to import some of the module that has been already predefined in your Python application. That module I am going to import the module. Based upon the module, some of the function is already predefined here, and based upon that function, I am going to run this particular topic. Clear about this? Have you clear what I told? Are you clear? Wow.
Yes, sir.
Mohammed Nasir, are you there, Nasir? Nasir?
Yes, sir.
Nasir, are you clear what I told now?
Yes, sir.
Yes. And Praveen?
Yes, sir.
Praveen, are you clear now what I told?
Yes, sir.
Yes. So again, I am telling that in the previous example, what we have done in a lines of code, we have defined a class, defined a function, and based upon the class, we have created an object. Based upon the object, we will call a function for that particular program. Like that, we have do some of an operation in the previous binary tree and heap tree, sorting methodology and all. So in this heap structure, heap tree concept, binary heap concept, I am not going to use any functions or a class inside the program. I am going to import only the heap queue property from the Python application, and based upon the heap queue property, all the functionality has been predefined in the heap queue module, and based upon some of an functions, I am going to execute this particular program. This is only for a theory part. I am working onto the code while using this class and function. Once I have completed those codes, and we will move with the class and function concept in your lab exercises, right?
Okay, sir.
So, yes. So now we will move. So this is a heap module. The heap module for finding out the module which will be only having is to finding out the minimum heap in to create a minimum heap in a binary heap concept. To create only a minimum heap, we can use this import heap queue concept. So I will explain you the code. So before that, I want to import so this is my import function. It means heap queue is one of a module that was predefined in a program in a Python application. So whatever operation we have discussed in the previous classes, that operation will be involved in this heap module that called heap queue. So whatever function you are calling now, that function will be automatically work. We no need to rearrange those function again and again. So first thing, I want to declare a list. So list 1 is equal to 5, 7, 9, 1, and 3. So just imagine. So this is my list 1. So it was kept in an array. How the structure will be for the list 1? What is my root node?
5.
So 5 is my root node. 7 is left hand side, and 9 is right hand side. 1 will be here, and 3 will be here. Is this right?
Yes, sir.
Yes. So this is known as, we are going to create a minimum heap in this concept. We are going to create a minimum heap. whether this tree has satisfied the complete binary tree property?
Yes, sir.
Yes. Whether this tree has satisfied the min heap property?
No.
No. So where you got an error, you will get an error in this stage, right? In this stage you will getting an error. So what I have told you that we want to swap those number here, and again you want to check, and you want to swap those number here, and again you want to check. This is the normal process we want to do in your function and class oriented concept. So in this, when you are going to use a module concept, then you can directly call the module, that is heap q dot heap p5, that means list 1. You can directly call the concept and you can directly print those things. So if I am printing this, print list 1, print list 1. So when after modifying this tree, how the structure will be? The final structure of the min heap will be like this, right? 1 7 9 5, sorry, it will be coming 5 here, 5 7 3 9 5 and 7. So I will run this first. 1 3 9 7 and 5. So this, you can see here, this is my first list, that is 5 7 9 1 3. So that list I have been printed here. So that list I have been printed after getting my list values, and after that I am just using this heapify method. It means it will heapify the concept based upon the minimum tree. Based upon this formula and execution will be occur in this heap q module. So no need to again and again, you no need to describe those things. If you are using this function heap q dot heapify function, then the list will be automatically rearranged based upon the minimum heap property, that is 1 3 9 7 and 5. So that will be an output here. So the after heapifying all the things, 1 3 9 7 and 5. So now you can tell me that whether this is a complete binary tree.
Yes.
Yes. Whether it has been satisfied the max min heap property.
Yes, sir.
Yes. So you can see here the root node is minimum than the child node. Here also the root node is minimum than the child node. So what we want to do, once you are doing the calculation manually, you want to describe a function, and after that you want to check with the root node, and you want to check with the child node, what all the nodes you want to check. So apart from that, if you are going with this module statement, that is heap q module, you just need to give this heapify functions over here and give the list name, and it will be printing that heap maximum, final, maximum, minimum list over there. Clear about this? Yes. Clear?
Okay.
Yes, sir. Clear.
Yes. Now we can go with another function, heap q dot heap push of list 1, comma, I can push the number 2. If I am going to push the number 2, here where the number 2 want to be represented first?
Place of 3.
Yes. So push in the sense we want to add a number over
last
here.
element at last.
Yes, at last. So it means here we want to add the number 2, right? Am I right? So this is my last statement after completion of this. So again you want to check whether this is a complete binary tree. Yes, this is a complete binary tree, and again you want to check whether it has been satisfied the minimum heap property. Yes, no, this not has been satisfied the minimum heap property. So you want to interchange this. 2 will be coming here and 9 will be coming here, right?
Yes, sir.
And again you want to check whether this is a complete binary tree. Yes, complete binary tree. Whether it has satisfied the minimum heap property. Yes, it was satisfied. So now the result will be 1 3 2 7 5 and 9, right? Yes.
Yes, sir.
Yes. So now after pushing this two number, you want to get the result as 1, 3, 2, 7, and 9. So now I am printing list 1. 7, 5, and 9. You can see here the output, right? 1, 3, 2, 7, 5, and 9. You can see this. After pushing the 2 to the minimum tree, it will allocate the process where it wants to be, and it will be displaying the output. So this is the function that you are using, that heap push function in a heap queue module. If you are not using a function, then you want to take this 2 and you want to insert an element in the last, and after that you want to compare with the parent node, and after that it was not satisfied, you want to swap those numbers, and after swapping the numbers, again you want to check whether this is a complete binary tree or not, and again you want to go with this swapping concept if it is not satisfied. So all the process has been included in this import function. So you want to do only one operation, that is a heap push, and whatever the element you need to push, you can push over there. Clear?
Sir, we can push many elements, like 2 or 3 also.
Yes, you can use another thing also, heap q dot heap push list 1, 100. You can see the 100 will be the highest position, so it has been went to last. So what it means, we want to insert in the end of the list. So this is my end of the list. Yes, I am inserting an element. So first you want to check whether this is a complete binary tree. Yes, it is a complete binary tree. And again you want to check whether all the elements has been utilizing the minimum heap property. Yes, it will be using the minimum heap property. So the 100 will be in the last position. If suppose I am pushing one more thing, that is heap q dot heap push list 1, 0. Now you can see where the root node has been changed. Are you getting my point?
Yes, sir.
Yes, because this is the lowest element in the minimum heap, 0. So that want to be in a root node. So while you are inserting the root node of 0, after this process, where the 0 will be inserted, the 0 will be inserted here. This is my first step. The 0 will be inserted here. After inserting, what will happen? It will check with this, and this will be swapped. This will be 7 and this will be 0, and again it will be checked with this. So this will be 0 and this will be 3, and again it will be checked with this. So 1 will be coming here and 0 will be coming here. So 0, 1, you can see an output there. 0, 1, 2, 3. So 2 is already here. 0, 1, 2, 3. And likewise, it will be move on. 5, 9, 100. Likewise, it will be move on. And final last element will be your 7th element that was inserted lastly. Clear? I want to explain one more time.
Clear, sir.
Yes,
Yes.
this is a heap push. This is a heap push concept. No need to worry about this operation and all. That we will discuss in the upcoming classes. And when I finalize the code, I will discuss you with an upcoming class. So this is an operation of push element. And next, what is the next element? Next operation.
Pop.
Pop.
Yes. Heap q dot heap pop list 1. That's it. So this is only one thing it will be difficult over here. If you are popping the element, the root node will be popped every time. The root node will be popped every time. So you can see. So now finally, what is my root node here? 0 is my root node, right? 0 is my root node. So now I want to pop an element from the list. So it means the push and pop operation what we have studied in a stack. So it means it will take the first element, that the root node will be eliminated, popped up. List 1. So now you can see here the root node has been popped and this element has been rearranged. You can see here this element, after popping this root node, the element will be rearranged. Can you see the difference here?
Yes, sir.
Yes. Yes. So you can see here. So once the 0, 1, 2, 4, 5, whatever it may be, 4, 5, 7, and 9, whatever it may be, 100. So once this has been popped, Once this has been popped, the minimum element will be coming as the root node, right? You can see the minimum element will be coming as your root node because this is a minimum tree. You can see the minimum element is 1. So the minimum element is coming as your root node. And here you are having 3 and this minimum element will be coming here. That's why that is 1, 3, 2. Likewise, it will be increased. So when you are do an rough work over this, then you can be able to identify easily how this pop function has been working out. Are you clear about this pop function? Push and pop, that means an insertion and deletion. Deletion of the root node, that is the thing. In a minimum heap, we are going to delete the root node, that is called as a pop function. Clear?
Yes, sir.
Yes. So now heap q dot heap replace list 1 comma, we have deleted 0, right?
Yes, sir.
Now the replace function. So we want to replace the root node with the sum of the node. We want to replace the root node with the sum of the node. You can see here I have replacing a root node by 0. Already previously my root node will be 1. I am going to replace that root node by 0. If I am changing this 1 as 0, then here no function will be changed. If suppose I am changing this 0 as 12, now you can see here the root, the number as we want to change this 1 as 12, and after changing the 1 as 12, the heapify operation will be working over there and it will be producing the heap minimum heap property. It will be going with the minimum heap property and it will be displaying the result. So that is the thing. For this replace statement, you will want to write a maximum number of codes. When you are without using the modules, you want to write a maximum number of code. Here only one function, that is we are going to replace this 12 by using the root node. Previously the root node will be 1, so I am going to replace this by 12, and after getting the 12 it will check whether this is a complete binary tree or not. Yes, this is a complete binary tree, and after that the 12 will be in the root node, so it won't be a min heap property, it won't satisfy the min heap property, and it will do the heapify operation and it will be producing the result like this. So if you are doing the homework there with this same example, then you can identify easily. So that is the process of replacement of the root node. And next operation will be to finding out the largest and smallest in the heap tree. Heap q dot heap dot heap q dot n largest n largest of 3 numbers. I need a last 3 numbers I need in the list 1. So this is the tree. I'm going to print the largest number in the particular list 1. What is my largest number? Last previous 3 numbers I need to print. So here I can see here 10 is my largest number, and 12 is the next largest number, and 9 is my next largest number. You can able to see this. So in this particular list, what is my largest number? That is 100, right? Yes.
Yes, sir.
Yes, and next largest will be the 12, and next largest will be 9. So these 3 numbers will be printed. If suppose I am giving here to print the largest of only one number, then the 100 will be displayed. Here I want to print the largest of 4 numbers in the particular list. Then the largest, first largest, second largest, third largest, and fourth largest. So if I am giving here as 3, 5, and I will print that till 5 largest number will be displayed. So to find out the smallest number in a heap tree, heap q dot n smallest. How many numbers you want, you can take. List 1. So this is my smallest number, that is 2. So this is my final tree, 2, 3, 9, 7, 5, 12, and 100. So this is my smallest number, that is 2 and 3 is my smallest number. If I am giving a range between 5, and it will be printing 2, 3, 5, 7, and 9. Clear about this operation? So this is the operation that will be required, and this operation we want to return this in a function module. So I'm not going now as in the function module. I'm just importing this heap cube modules over there, and I'm getting this function, and I'm doing this operation. So these are the operation. You are clear about the operation, what it will do, right? Yes.
Yes, sir.
Yes, sir.
Yes. Arjun, are you there, Arjun? Arjun? Yes, Arjun. Can you unmute yourself?
Yes, sir.
Yes, Arjun. Are you clear about this concept?
Yes, sir.
Yes. Any doubts here?
No, sir.
No. Thank you. So that is the thing. So this is the simple basic operation that was in the minimum heap. Once again, I am telling that only this module which will be representation of the minimum heap. If they are asking in a 2 mark or a 8 mark question, then you can go with this type of code for the minimum heap property. If they are asking in a 16 mark question, then you want to go with the function and class structure that I will be explaining you later. So next one, I am giving the another example. Now I am giving the list 2 is equal to, I'm getting a function called MADAN. So before this, so now you tell me what will be my root node.
NIT.
What will be my root node? NIET my root node. Yes. So I am giving this root node as NIET. And what will be my, so this is a different topic. This is not a minimum heap. This is not a minimum heap. So I'm once again I'm telling this. This is a priority heap. This is a priority heap. This is not minimum heap. This is minimum heap as I've completed. These are all the operation. Likewise, you can do for this. As of now, you can do work out this code, and the remaining codes I will be explaining you later. So this is not a minimum key. I'm once again I'm telling. This is a priority heap. I'm going to explain this. We can use the priority concept inside the tree also. So that is the thing I'm solving. So now this NIT is my root node. What is my left child?
AIDS.
ADS.
AIDS will be my left child.
CSDS, right.
CSBS will be my right child, and in this
AIDS
AIDS,
left to NGI.
NGI will be my child node. So now I have given the data over here, that is a string over here in a list. I am giving a string over here, and I want to give the priority option, which one we want to take first and which one we want to take second. So likewise, I want to give some of a priority in my list. For this priority, I have I will give a keyword over here for each and individual string that I have represented. If suppose I am giving this NG, I want to be my first priority. In this particular list, NG, I want to be my first priority. And here, NIET want to be my second priority. And after that, AADS want to be my third priority. And fourth will be the CSBS. So this is the priority list I am giving to this particular string that I have inserted in a list. So if suppose I am giving this priority over here, you can give and you can do a lot of operation to insert. You can do an operation by used upon the priority key what we have given over here. So after the priority key, what is my first priority in here?
NGI.
What is my first? So NGI is my first priority, and second priority will be NIET, my second priority. So it means I am giving a priority structure here, but I am not used an order element over here. But the thing I have given a priority for each and individual string that want to be represented in a tree. So second priority is NIET, and third priority will be ANDS, and fourth priority will be CSPS. So finally, the tree structure, if you are giving this priority, then final tree structure will be like this. We no need to arrange the elements in an order. You just give the priority. Can you tell me where you have studied this keyword priority in the PSPP? Based upon the keyword, it will be working in the function.
Dictionary.
Yes, dictionary, good. So in this dictionary, we will give some of a keyword, and based upon the keyword, we will call you some of an values, right? So same thing that I am using in this heapify concept also. Based upon the keyword, it will call and it will be allocate the particular memory for the particular node. So for I in range print q dot heap. What is the function I want to use to insert an element one by one?
Push.
To show you the element one by one. So this, when you are using this heapify concept, it has been arranged. That has been arranged. All the element has been arranged. Here I have what, in which operation I have show you the element has been described. Pop function. It will take the root node first, right? What is the value?
Yes,
What is the? It will take the root node first, and it will be displaying you the result. So which priority it has been arranged? When you are heapifying the concept based upon this structure, this will be automatically arranged. When you want to show to the user, this pop function will be used. When you are using the pop function, first it will be taking the root node from your tree. List of 2. So now you can see. So what is my first priority has been came out?
NGI.
NGI. So this is my first priority. It means that is my root node. When the first pop operation has been occurred, that is my root node. So once this has been deleted, what is my next priority I have given? That is NIET. So that will come as your root node. So after popping up the NIET, popping up the root node, the NIET will be terminated and it will be coming out. And after that, the AADS will be the root node. Act as AADS will be the root node. And after popping up the AADS, only CSBS will be available. That will be your root node. And after that, popping up the root node, the tree will be empty. There is no operation has been left out over there for the particular tree. Are we clear? You can give us n number of that. So once again I'm telling this is not a minimum operation. This is the priority queue that you are going to insert in a minimum heap property. Priority queue. That is the thing. Clear about this? Any doubts?
No, sir.
Hari Krishnan, are you there, Hari Krishnan?
Yes, sir.
Yes, sorry, Krishnan. Have you clear about this? What I have explained now?
Yes, sir.
Yes. Prasant from AIDS. Prasant. Nandakumar. Yes, Nandakumar. Have you clear about this? Yes. Thank you. Thank you. So once again, I am telling that I am not using any functions or code over here. I am just importing a module. So that's it. So this is your question banks. I hope so. You have. I will share you this. So I am having 16 2-mark question and with me, and that will be the direct questions. So you can search these questions in your Google also, or else you can write in your own words. That's not a problem. So in this 8 marks, I having a 13 binary heap tree application. Yes, I am having a 13 questions. Bubble sort, selection and merge it will be combined, and merge and quick it will be combined. So binary search, linear search, and this is a hash function that we have discussed, and hash table operation and function. This is a theory part. You can take your own example and you can write your theory part. And tree terminologies and characters. This is your theory part, and types of benefits of binary tree. This is also a theory part. And here the binary search algorithm to represent the insert, delete, in order, and maximum, to find out the insert, delete, in order, and maximum. And one more questions will be there to find out the create, insert, delete, pre-order, post-order, and minimum. So this will be 2 types of questions will be there. We have split the question in 2 types. One is in the binary search, and after that the AVL tree operation and notation that we want to discuss. Whatever the example we have taken, based upon the example, we want to do an operation and the rotation of the AVL tree. And now the binary heap application and operation. For this internal 2, you can go with the module operation. Whatever the module I have described and function we have described, so you can go with this module lines of code. That's enough. And the thing, I will give you a sorting method in a question paper. I am not giving you, I am not let you to take your own example. I will give you an example in a question paper. Based upon that example, you want to sort those bubble and insertion sort. If you are writing this question, that is, if you are writing the first question of bubble sort and insertion sort, you want to describe how it will be work and what are the algorithm for bubble and insertion sort. And after getting those bubble and insertion sort, you want to go with the lines of code of bubbles and insertion. And after the lines of code, you want to explain how the process will be working for that particular input you are getting, right? For that input, I will give you an input. You don't take the input. I will give you an input. Based upon the input, you want to describe a diagram over there, and you want to write those things. So that is the bubble sort and insertion sort. So we don't know. I will give most probably I will give you an individual element for each and individual. I won't give you like this. When 2, 7, 9, 0, 2, 1, 13, 334, 45, 6, 7. Like that, I won't give you the single element for all the 60 members or 39 members. I will give you each and individual a single set of elements. Based upon this, each and individual a single set of element, you want to work out those things and you want to present in the paper. That is the thing. Clear?
So say 6th question, sir.
Huh?
6th one, sir.
6th one, that is the hash function. We have discussed about the separate chain hash table and open addressing hash table. We have discussed in the 3rd unit. I will share you the PowerPoint. When you are seeing the PowerPoint, you can easily understand that this is an example. This is a mod function that you are going to use, and you can take any example. The set will be given to you in the question paper. For which set you want to do this separate chain hash table and open addressing hash table. I will give you the set of question in a question paper, and based upon the set you want to do the calculation. That is the thing. And the sorting method for each, as of now I am having a only idea to give a common table list to all of them. If time permits, I will give you each and individual elements. Individually I will share you the elements in the classroom. It will be in an Excel sheet. In this, the name will be displayed, and based upon the name, you want to sort this as a bubble sort or you want to sort this as an insertion sort. So each and individual, you will get an element to sort, and you want to describe those elements individually. That is the thing. Any doubts in this? So I will share you this. After finalizing this, I will share you this. Any doubts? Any doubts? So next class we will look after the minimum search tree, that is the B tree. So B tree concept and there is no lines of code in a B tree. Only the theory part and algorithm part will be there in the B tree. So only one topic which was pending in the 4th unit, that is a B tree concept. So I will explain you that in the next class. And so that B tree will not be added in your internal too. As of now, the what this topic we have discussed, binary heap tree application and operation, that will be added in the internal 2 option. So the thing, I will give you a number to sort, and based upon the number you want to sort and you want to explain those algorithms and program. That's the thing. Any doubts or suggestion, or I want to do some of the changes, you just inform me. You can ping me directly. You can ping me and you can ask your queries. So as of now, if you are not having any queries, just give your attendance and you can leave the class.